right, so I think I'm on my 5th attempt at trying to record this. I'm hoping we have sound. I'm hoping everything works this time. So we're going to do part 2 of quadratic functions, which goes with chapter 3.1. Minimum, maximum. Remember, if A, we learned yesterday, if A was greater than 0, if it was positive, your graph opened up, which would make your vertex a minimum, a lowest point. We learned that if A was negative, our graph would open down, so that would make our vertex a maximum point. So depending on which way it opens, you could have a minimum, a lowest point as your vertex, or a maximum, a highest point as your vertex. So it says determine without graphing whether the function has a minimum or maximum. So we see here our A is positive 4. We're opening up. No. Let me change it real quick. We're opening up. So if we're opening up, that means our vertex is our lowest point. It is a minimum. Next one says find the minimum or maximum value and determine where it occurs. So let's determine where it occurs first. We want to find that vertex. So we have x equals opposite of b over 2a. Opposite of b is positive 16. 2 times 4 gets me 8. 16 divided by 8 is 2. So where does it occur? It occurs at x equals 2. It occurs at 2. Now, what is the value? What is the value? We're actually going to plug that in and find out what is that lowest point. What is my y-coordinate? So we have 4 times 2 squared, 16 times 2 plus 1,000. So we've got 4 times 4 is 16 minus 32 plus 1,000. And it looks like we're going to get 984. So your value, your lowest point, is going to be 984. 984. Identify the function's domain and range. Now, I like to do this from an actual graph. So you can just do a rough sketch. We know our vertex is at 2, 984. Definitely a rough sketch. We know it's opening up. We're just going to pretend that's 2, 984. So domain is all real numbers, negative infinity to positive infinity. Now your range, right? Your range, your lowest point, your lowest y value is 984. Remember, we use brackets, and we're going all the way to positive infinity. All right, next one. So this is that real world application, right? When am I going to use this stuff? Talking about trajectory, if you want to talk about, something that's going to go up and come back down. So this is talking about an archer's arrow. I've seen football, baseball used, a dolphin jumping out of the water. So you're looking for that parabolic, something going up, something coming down. A ball bouncing, that, again, going up, coming down. So this gives you a function, right? Gives you a function. Now we know with that negative, we're going to be opening down, right? And think about an arrow. You're going to shoot it up. It's going to come back down. What is the maximum height? So they want, what is that maximum? What is my highest y value? And where does it occur? So let's go ahead and do our formula. All right, we want to find that vertex, opposite of b over 2a. So we've got opposite of b over 2 times a is a little bit longer, 0.005. All right, so we got x equals 2 divided by negative 0.01. X equals 200. So how far? 200 feet from release. 200 feet from release is where my arrow will be at its highest maximum height. Sorry, maximum height. So let's plug it in and find out what that maximum height is. So we have y equals negative 0.005, 200 squared, 2 times 200 plus 5. We're definitely going to use calculators here. 200 squared times this gets me negative 200 plus 400 plus 5. So we wind up getting 205. So again, think about what this is representing. This is our highest y value. So that's our maximum height, is 205 feet is our max. Maximum height. The next one says find the horizontal distance. So horizontal distance, start to finish. The arrow travels before it hits the ground. Round to the nearest foot. So understand you need a starting point and an ending point to find that horizontal distance. Where did I end up? So we don't want any height, right? We want our height to be 0 in this case. We're finding our x-intercepts. 0.005 x squared 2x plus 5. Now when I look at this, I'm going to jump straight to the quadratic. Opposite of b plus or minus square root of b squared minus 4 times a times c. And all of that is over 2 times a. Calculators are going to come in very handy here. So inside you're going to wind up with 4 plus 0.1. On the bottom, negative 0.01. And we're going to go ahead and pause there. That's what you just want to type in a calculator. Negative 2 plus root 4.1 divided by, and negative 2 minus root 4.1 divided by. And you should get 2 answers. Now one of them seems kind of silly, and the other one makes a little more sense. So here we're talking about the horizontal distance traveled. This intercept doesn't make much sense to me, but this one does. So it's going to travel 402 feet. And we're going to go ahead and graph. So we're going to count by hundreds because I'm a little bit lazy. So we're going to say 100, 200, 100, 205. Pretty close to 200. I don't know why this is not letting me do it. There we go. And then we know we cross at 402. 1, 2, 3, 402. Now, I also kind of want to see my starting point. So I want that y-intercept, right? Your y-intercept is going to be 5. So you know you're here-ish. So I had a question in class today. Do I have to put the arrows? So on a normal parabola, yes. But for this problem, think about an arrow. We're not putting, think about an arrow, an archer's arrow, and the path it takes. We're not going to put arrows on this graph because you're going to start. You're going to shoot the arrow. You're going to go all the way up till you reach your maximum height of 205 feet. And then you're going to come back down. And you're going to wind up 402 feet away from the start. So that's kind of what this is talking about. All right, no arrows, because again, it goes up, comes down, stops. It doesn't keep going. You can also use minimums and maximums for products. So we're going to go ahead and try this out. This says find a pair whose product is as small as possible. Product means multiply, so we're just going to say the product is x times y. All right, we need a pair of numbers. They also say the difference of those two numbers is 8. So if I subtract them, I should get 8. Now I'm going to go ahead and use substitution. So I'm going to get y alone. Add y, subtract 8. So now every time I see a y, I can plug in x minus 8. So we're going to come back here, x times, and instead of y, we're going to put x minus 8. We're going to go ahead and distribute x squared minus 8x, and there's our function. There's our function. Now this function's opening up, so when they're asking you for the minimum, they're asking you for the minimum, what's as low as the product can get. What's as low as that product can get. So we want that vertex, right? X equals opposite of b over 2a. So opposite of b is positive 8 over 2 times a, which is 2. 8 divided by 4. 8 divided by 2 is 4. So there's one of them. There's one of our numbers. And we're just going to plug it in here. Y equals x minus 8. So x was 4 minus 8 gets me negative 4. So there's my two numbers, but we're going to go back to the question. What is the minimum product? So product means multiply. So 4 times negative 4 gets me negative 16. So that's the smallest product we can get of two numbers whose difference is 8. All right, next one says you have 120 feet of fencing to enclose a rectangular region. So we have a rectangular region. We've got a length and a width. I'm going to call them x and y. Now, if you're fencing this in, you're thinking of perimeter. So if you have 120 feet of fencing to go around, you need your perimeter to be 120 feet. So we've got 1x and 1x makes 2x plus 2y. Remember, perimeter, add up all your sides. And we want it to be 120. And it says find the dimensions of the rectangle that maximize the enclosed area. So area would be length times width, right? In this case, x times y. So we're going to do that same thing. We're going to get y alone. So I have 2y. We're going to subtract 2x from both sides. And we're going to divide both sides by 2. So I got 60 minus x. That's an x. And now we can go ahead everywhere we see these are y's. They do not look like y's, do they? I'm going to make them look more like y's. There we go. Every time we see a y, we can plug in 60 minus x. So we have x times 60 minus x. So we have 60x minus x squared. We're going to put that in standard form. And we're going to think about this parabola. Right? We're going to think about this parabola. It's opening down. So that top is my maximum, right? And that's what they're asking for. What's the maximum area? All right, so let's get it. X equals opposite of b. There's an x here. My bad. Opposite of b over 2 times a. You get 30. If we want to find y, we're going to plug it right in right here. So y equals 60 minus x. Y equals 60 minus 30. So you got y equals 30. Now we're going to go back and read. What is the maximum area? So max area would be 30 times 30, which would be 900. And we're talking about feet squared because we're talking about area. All right, that's it for today. Sorry about all the confusion. Bye, guys.